Today we are talking about vaccines as a therapeutic option with Professor Ulrike Protzer, Head of Virology at the Molecular Targets and Therapeutic Center. How do you define targeted therapies?
As somebody developing vaccines or immune therapies, you define targeted therapies slightly differently. It's not so much a molecule in a cell which you target, it's more a distinct cell of the immune system or an arm of the immune system which you try to activate. Or sometimes it's also a molecule on the surface of cells, so-called immune checkpoints, which regulate immune cells.
Which are the molecular targets of viruses?
Viruses offer their proteins, their enzymes as molecular targets. And you have to understand the virus exactly and its replication mechanism to really be able to know which one of the proteins you should target to achieve a certain effect.
What are the difficulties in developing a vaccine against a virus?
There's already quite a number of vaccines against viruses which we have available. However, there is some which we are missing. Examples are hepatitis C virus or HIV. Why? Because these viruses, they mutate very rapidly. They just escape, and it's very hard to design a targeted vaccine. Or what hepatitis C virus does, it even sort of envelopes into a lipid particle, and thus it cannot be recognized by the immune system.
How important is structure-based research for the development of vaccines?
Structure-based research is very, very important for the development of vaccines, because only if you understand the structure of a virus protein exactly and you exactly know what it's looking like, then you can develop a targeted vaccine. I think COVID-19 vaccines are good examples. Those who understood the structure of the spike protein and were able to model it and to mimic it, those were the successful vaccines.
What is the essential difference between protective vaccination and a therapeutic vaccination?
There's a major difference between the two types of vaccinations. Prophylactic vaccines are made to prevent an infection, to inhibit a virus from entering the body, or if that's not possible, at least preventing the disease developed in response to the virus. A therapeutic vaccine is a therapy. That means you have somebody who already suffers from a chronic infection, and this chronic infection causes a disease, and that's what you want to fight. And for this, you activate the immune system to get this bug out of the body.
In your opinion, what is more promising in the fight against viral infections, the development of therapeutic vaccines or of antiviral drugs?
To really fight a virus, you need both. You need antiviral therapies and you need vaccines. Why? The vaccine prevents the infection. If it doesn't happen, perfect. The antiviral controls the infection. That is often useful if the virus replicates too heavily or you have the opportunity to get it out of the body by inhibiting its replication. But very often then you also need the immune system. And if the immune system does not kick in by itself, you need to activate it, for example, by a therapeutic vaccine.
Where is the risk of resistance development greater? With vaccines or with drugs?
Certainly the risk that a virus develops a resistance is higher if you give an antiviral drug or a monoclonal antibody, which is also used as an antiviral. Why? Because that targets a very specific protein in the virus life cycle. And the virus can escape. They can just modify this one protein. Against a vaccine, it's much harder to escape for the virus because the vaccine activates a broader response against different parts of the virus and also activates different arms of the immune system. And there it's really hard for the virus to escape. And I think that's nicely demonstrated by now by the COVID-19 variants, where they are resistant against part of the drugs, not all of them, but the vaccine still works.
What role do vaccines play in fighting chronic infections, such as hepatitis B?
Once you have a chronic infection and have this virus permanently in your body, a prophylactic vaccine obviously does not help anymore. So what you need is something which then stimulates your immune system to drive the virus out of your body. And that could be a therapeutic vaccine or also some other immune therapies, but a therapeutic vaccine is a very promising approach.
Does the future of vaccine development lie in RNA vaccines, analogous to COVID-19?
The RNA vaccines offer a new platform, which we did not have in our hands before, but now we have it. And now obviously we will use it for different vaccine developments, not only against viruses, also against bacteria, parasites, or even against cancer.
Can we dream that in the future there will be vaccines against civilization diseases such as cancer, diabetes, or heart attacks?
Dreaming is always important, but you also have to be somehow realistic. I think developing vaccines against immune-mediated diseases or immune-controlled diseases, there is a very bright perspective. For example, cancer vaccines, they have a perspective. Other example would be type 1 diabetes. It's also an immune-mediated disease, or asthma. For these, we can use vaccines. However, for other diseases like heart attacks or strokes, it's much harder to do that because the mechanisms are completely different.
In earlier times, life-threatening infections were the main cause of disease. After the Second World War and better hygiene worldwide, as well as the development of antibiotics, the focus shifted to civilization diseases, such as cardiovascular diseases, diabetes, cancer, etc. Recently, infections, primarily viral, have suddenly threatened people's health again worldwide. AIDS, hepatitis, corona. How does this increased occurrence of viral pandemics come about?
We could achieve, after World War II, a better control of infections because we had antibiotics in our hands. We had hygiene measures which were improved, and we had vaccines, which is the most important part of the control. However, there is still some viruses where we never had a vaccine, where we don't have enough treatment, and we have antibiotic-resistant bacteria developing. So there was always a threat by infectious diseases, which was maybe a little bit neglected, but it was there. And now on top, there is an increasing risk of emerging infections. Why? Because we have climate change. We have mosquitoes who change their environment. We have humans and animals coming closer together, so a transmission of a virus becomes more likely, and we have increasing international traffic. And all this favors the spread of pandemics, like we have learned with the COVID-19 pandemics the hard way.